Baik. Visual background ada di
Tokecang bala gendir, tosbong angen kacang sapariuk kosong. Tokecang bala gendir, tosbong angen kacang sapariuk kosong. Aya listrik di masikit, manica angkat tinggalna. Aya istri jangkung alit, karangan dina pipina. Tokecang bala gendir, tosbong angen kacang sapariuk kosong. Tokecang bala gendir, tosbong angen kacang sapariuk kosong.
Selamat pagi Bapak Ibu. Terima kasih bagi Bapak Ibu yang sudah join pada acara bimbingan teknis Balai Sains hari ini. Untuk waktunya akan dimulai pukul 9 pagi. Berikut saya bacakan terlebih dahulu untuk tata tertibnya. Bapak Ibu mohon mematikan mikrofon selama acara berlangsung, namun dapat mengaktifkan mic-nya saat akan berbicara ataupun bertanya dengan menggunakan fitur raise hand terlebih dahulu dan menunggu dipersilakan MC ataupun moderator. Bapak Ibu juga dapat mengajukan pertanyaan melalui kolom chat dengan format yang sudah tampil pada layar Bapak Ibu, yaitu nama, _instansi, _ kepada narasumber, underscore pertanyaan yang akan diajukan. Bapak Ibu juga kami persilakan untuk dapat menggunakan virtual background yang telah di-share oleh tim panitia dan dapat mengisi kuesioner dan absensi di akhir acara nanti. Bapak Ibu juga dimohon kerjasamanya untuk bersama-sama menjaga ketertiban dalam lisan ataupun perilaku selama acara. Bapak Ibu diharapkan dapat mengikuti seluruh rangkaian acara dengan utuh.
Angin mamiriku pasang ditujui tongtonganan tu sarua takkan lupa tatuni angin mamiri angin ngerang dingin-dingin nama lontar sari kuku aule nama urai tu tenaya
Daerah sini kan ya?
Marisina tatuni angin mamiri angin
Buat nata rambut.
dingin-dingin nama lontar sari kuku aule nama urai matolorang jene mato
di offline di ruang rapat di BTPP. Sebelumnya kami ucapkan selamat datang kepada yang terhormat Direktur Bina Teknik Permukiman dan Perumahan, Ibu Dian Irawati. Selamat pagi Ibu. Kepala Balai Sains Bangunan, Bapak Ajun Haryono. Pemateri Dr. Takashi Asawa. Good morning, welcome to Bandung, Dr. Takashi. Moderator Dr. M. Nur Fajri Alfata. Para direktur di lingkungan Ditjen Cipta Karya dan Ditjen Perumahan. Para kepala BPPW di lingkungan Ditjen Cipta Karya. Para kepala subdirektorat dan kepala balai teknik di lingkungan Ditjen Cipta Karya, para peserta bimbingan teknis di lingkungan Ditjen Cipta Karya dan Ditjen Perumahan, dan Bapak Ibu yang sudah hadir secara offline maupun online melalui Zoom dan platform YouTube. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya. Selamat pagi Bapak Ibu dan salam sejahtera untuk kita semua. Puji dan syukur kita panjatkan kehadirat Allah Subhanahu wa Ta'ala, karena berkat rahmatnya kita dapat berkumpul melalui Zoom meeting dan secara offline pada hari ini, Kamis, tanggal 3 November 2022, dalam acara Bimbingan Teknis Sains dengan tema Simulation-Based Design for Built and Urban Thermal Environments. Bapak Ibu, sebelum memulai acara, izinkan saya selaku pembawa acara untuk membacakan susunan acaranya terlebih dahulu. Menyanyikan lagu Indonesia Raya dan Mars PU, laporan penyelenggaraan kegiatan bimbingan teknis, sambutan pembukaan, foto bersama, penyampaian materi, dan dilanjutkan dengan diskusi, kemudian ada post test, dan terakhir yaitu penutupan. Sebelum memulai acara pertama, mari kita buka acara dengan membaca basmalah. Bismillahirrahmanirrahim. Menyanyikan lagu Indonesia Raya dan dilanjutkan dengan Mars PU, hadirin dimohon berdiri. Sing the National Anthem Indonesia Raya and Ministry of Public Works March, and for offline participants, please raise from your seat. dimohon duduk kembali. Baik, Bapak Ibu, laporan penyelenggaraan kegiatan yang akan disampaikan oleh Kepala Balai Sains Bangunan kepada yang terhormat Bapak Ajun Haryono, kami persilakan.
Assalamualaikum warahmatullahi wabarakatuh. Yang saya hormati Ibu Direktur Bina Teknik Permukiman dan Perumahan, narasumber kita, Profesor Takashi Asawa, para direktur di lingkungan Ditjen Cipta Karya dan Ditjen Perumahan atau yang mewakili, para kepala BPPW dan para kepala BP2P atau yang mewakili, para Kasubdit dan Kabalai Teknik di lingkungan Direktorat BTPP dan atau yang mewakili, dan para peserta bimbingan teknis yang sudah hadir secara luring maupun daring. Selamat pagi hadirin semua. Alhamdulillah pada hari ini kita dapat berkumpul bersama dalam mengikuti bimbingan teknis Sains Bangunan. Bapak Ibu para hadirin yang saya hormati, pertama-tama izinkan kami menyampaikan ucapan terima kasih atas perhatian dan antusiasme Bapak Ibu sekalian yang telah menghadiri acara bimbingan teknis ini. Terkait penyelenggaraan ini ada beberapa hal yang perlu kami laporkan. Yang pertama, materi yang akan disampaikan adalah terkait simulation based design for built and urban thermal environment, dengan tujuan untuk memberikan tambahan bekal pengetahuan teknis kepada kita semua dan juga penyegaran bagi yang sudah memahami untuk konteksnya dalam menunjang profesional pelaksanaan pekerjaan di Kementerian PUPR. Dengan adanya kegiatan bimbingan teknis ini yang bertema tersebut tadi, diharapkan kita dapat belajar secara aktif dan berdiskusi bersama terkait yang pertama adalah perencanaan bangunan gedung dan lingkungan binaan. Yang kedua adalah terkait metode simulasi dalam merencanakan objek tersebut gitu untuk bangunan yang berkelanjutan. Materi akan disampaikan oleh narasumber yang sangat kompeten di bidangnya, yaitu Profesor Takashi Asawa, Associate Professor of Transdisciplinary Science and Engineering, Tokyo Institute of Technology. Penyampaian materi ini akan membahas topik baru yang kedepannya diharapkan dapat diterapkan di Kementerian PUPR dan turut mewujudkan infrastruktur yang berkelanjutan. Bapak Ibu hadirin yang saya hormati, pelaksanaan bimbingan teknis hari ini diselenggarakan dalam waktu 1 hari dengan durasi selama 2,5 jam. Selanjutnya kami laporkan per jam sekarang yang sudah bergabung via Zoom adalah 200 peserta dan ada juga yang bergabung melalui YouTube. Mengakhiri laporan penyelenggaraan ini, kami ucapkan terima kasih kepada hadirin yang telah berkenan hadir dan mengikuti acara ini, kepada tim pelaksana yang sudah menyiapkan segala sesuatunya dengan baik. Pepatah mengatakan tidak ada gading yang terletak, begitu pula dengan penyelenggaraan kegiatan ini. Oleh karena itu kami mohon permohonan maaf yang sebesar-besarnya jika ada yang kurang berkenan. Akhir kata, kami mohon kesediaan Ibu Direktur Bina Teknik Perumahan dan Permukiman untuk dapat memberikan arahan dan membuka acara BIMTEK ini secara resmi. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Baik, terima kasih Bapak Ajun atas penyampaian laporannya. Selanjutnya yaitu sambutan pembukaan yang akan disampaikan oleh Direktur Bina Teknik Permukiman dan Perumahan. Kami persilakan yang terhormat Ibu Dian Irawati.
Terima kasih Ibu Putri atas waktunya menyampaikan sambutan pembuka ya. Bismillahirrahmanirrahim. Yang terhormat Profesor Takashi Asawa from Tokyo Institute Technology. Yang terhormat para direktur di lingkungan Ditjen Cipta Karya dan Ditjen Perumahan atau yang mewakili, para kepala BPPW dan BP2P atau yang mewakili. Yang terhormat di sini juga kepala Subdit dan Balai Teknik di lingkungan Direktorat Bina Teknik Permukiman Perumahan, dan juga seluruh peserta bimbingan teknis Sains Bangunan, baik yang hadir secara luring maupun daring. Assalamualaikum warahmatullahi wabarakatuh. Salam sehat dan salam sejahtera untuk kita semua. Pertama-tama kita ucapkan puji syukur pada Allah Subhanahu wa Ta'ala, Tuhan Yang Maha Esa, karena atas rahmat dan karunia-Nya pada pagi hari ini kita bisa berkumpul bersama dalam keadaan sehat walafiat guna mengikuti acara bimbingan teknis Sains Bangunan dengan tema Simulation Based Design for Built and Thermal Environments yang akan berlangsung dari pukul 9 hingga pukul 11.30. Selanjutnya saya ingin menyambut Profesor Takashi Asawa dari Tokyo Institute of Technology di kampus kami di Bandung. Semoga Anda menikmati kunjungan Anda di Indonesia, terutama di kampus kami Direktorat Bina Teknik Permukiman dan Perumahan. Kami senang dapat menyambut Anda serta dapat bertemu, berbagi pengetahuan dan diskusi bersama dalam kegiatan ini. Kesempatan kali ini merupakan pertama kalinya kami menghadirkan narasumber dari luar negeri sebagai pembicara utama dalam kegiatan bimbingan teknis ini setelah masa pandemi ya. Bapak dan Ibu sekalian yang hadir, saat ini kita menghadapi banyak tantangan di sektor bangunan gedung dalam kaitannya dengan isu perubahan iklim. Sektor bangunan gedung merupakan konsumen energi ketiga terbesar di Indonesia, sekaligus sebagai penyumbang emisi karbon. Tantangan lainnya adalah pengembangan Ibu Kota Baru Nusantara sebagai Smart City dan implementasi Peraturan Menteri PUPR Nomor 21 Tahun 2021 tentang penilaian kinerja bangunan gedung hijau. Semua tantangan itu mengarah pada satu kunci penting, yaitu bangunan gedung berkinerja tinggi atau high performance buildings. Bangunan gedung berkinerja tinggi adalah bangunan yang memiliki kinerja efisiensi energi dan kinerja sumber daya alam lainnya seperti air yang relatif lebih tinggi daripada yang diisyaratkan oleh peraturan bangunan atau peraturan lainnya. Hal ini juga menyeratkan bahwa desain berbasis kinerja atau performance based design saat ini lebih diperlukan daripada hanya desain berbasis perspektif atau hanya mengikuti persyaratan minimum yang ditentukan oleh NSPK terkait bangunan gedung atau building code. Pendekatan desain parametrik melalui simulasi komputer dengan demikian menjadi salah satu sarana untuk mencapai desain berbasis kinerja. Para peserta yang saya banggakan, selama 50 tahun terakhir, program simulasi energi dan thermal telah dikembangkan dan digunakan di berbagai bidang termasuk sektor bangunan gedung. Dalam prakteknya, perangkat lunak tersebut sekarang banyak digunakan untuk merancang bangunan berkinerja tinggi di seluruh dunia. Jika kita melihat best practice bangunan gedung berkinerja tinggi di seluruh dunia, kita dapat melihat peran program simulasi energi bangunan di sana. Dengan kata lain, menggunakan simulasi komputer tidak dapat dihindari untuk mencapai target pembangunan berkelanjutan. Sayangnya, penggunaan simulasi energi pada bangunan masih belum umum digunakan di Indonesia. Merancang bangunan di Indonesia secara praktis masih tergantung pada pendekatan berbasis preskriptif. Hal ini memang baik, tetapi jika kita ingin mengambil lompatan besar dalam menjawab tantangan saat ini, kita harus mulai menggunakan simulasi komputer sebagai alat untuk merancang bangunan gedung berkinerja tinggi. Simulasi komputer harus mulai diperkenalkan dan didorong untuk digunakan sebagai bagian dari desain. Dalam Peraturan Menteri PUPR Nomor 21 Tahun 2021, simulasi komputer telah disisipkan pada tahap desain, setidaknya untuk desain pencahayaan. Namun demikian, kita harus hati-hati melalui simulasi komputer. Jika tidak, maka akan berlaku garbage in, garbage out ya. Dengan kata lain, jika data yang dimasukkan salah, maka hasilnya pun akan salah. dan bukannya mencapai bangunan berkinerja tinggi, melainkan kita akan gagal dalam merancang bangunan dengan tepat. Bapak Ibu sekalian, hari ini kami telah menghadirkan profesor terkemuka dari Tokyo Institute Teknologi Jepang untuk berbagi ilmu dan pengalamannya dalam menggunakan simulasi komputer dalam topik ini. Silakan Bapak Ibu sekalian menggunakan kesempatan langka ini untuk menggali lebih dalam tentang topik tersebut, sehingga Bapak Ibu sekalian ya bertambahlah wawasannya ya. Semoga apa yang akan beliau bagikan pada kita pada hari ini dapat memberikan wawasan dan pemahaman yang lebih tentang peran energi pada bangunan dan simulasi thermal dalam merancang bangunan yang bisa mendorong kita semua menggunakan alat-alat tersebut secara inovatif untuk mencapai tujuan nasional kita, yaitu pembangunan berkelanjutan. Saya percaya ada banyak hal yang bisa kita pelajari untuk meningkatkan kualitas infrastruktur kita khususnya di sektor bangunan. Sebelum saya membuka sesi ini secara resmi, izinkan saya menyampaikan terima kasih sebesar-besarnya pada Profesor Takashi Asawa. Thank you Profesor Takashi Asawa for involve and coming share knowledge to us. Dan terima kasih juga saya sampaikan kepada Balai Sains Bangunan yang telah menyelenggarakan acara ini. Dan semoga banyak manfaat yang bisa kita terima bersama-sama untuk mengikuti acara bimbingan teknis pada pagi hari ini. Demikian akhir kata, dengan mengucapkan Bismillahirrahmanirrahim, saya menyatakan bimbingan teknis sains bangunan dengan tema Simulation Based for Design, Build and Thermal Environment secara resmi dibuka. Kami ucapkan terima kasih atas dukungan semua pihak yang telah berpartisipasi dalam penyelenggaraan bimbingan teknis ini. Terima kasih juga nih Pak Ariel sebagai narasumber juga, tandem bersama Pak Profesor Takashi. Selamat mengikuti bimbingan teknis. Semoga Tuhan Yang Maha Kuasa senantiasa memberikan rahmat dan karunia-Nya kepada kita semua. Wabillahi taufik wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Baik, Ibu Diani Rawati, terima kasih atas sambutannya. Bapak Ibu, sebelum ke paparan, kami akan melakukan foto bersama terlebih dahulu. Kami persilakan bagi Bapak Ibu yang sudah hadir pada Zoom hari ini untuk mengunduh virtual background yang sudah di-share di kolom chat dan mengaktifkan kameranya. Di sini sudah ada beberapa slide. Kami akan mulai hitung. 1, 2, 3. Selanjutnya 1, 2, 3. Dan terakhir 1, 2, 3. Baik Bapak Ibu, terima kasih atas senyuman manisnya. Selanjutnya yaitu paparan materi mengenai simulation based design for built and urban thermal environments yang nantinya akan dilanjutkan diskusi. Materi akan disampaikan oleh Dr. Takashi Asawa, Associate Professor from Transdisciplinary Science and Engineering, Tokyo Institute of Technology, Japan. Dan paparan materi ini akan didampingi oleh Bapak M. Nur Fajri Alfata atau yang biasa kita sapa Bapak Ariel selaku moderator. Paparan akan disampaikan dalam bahasa Inggris dan bagi Bapak Ibu yang sudah hadir secara offline di ruang rapat di PTPP dan ingin mendengarkan dalam versi bahasa Indonesia dapat menggunakan fitur interpreter pada bawah bagian Zoom. Sebelumnya kami juga ingin menginformasikan bahwa pada pukul 10 nanti akan diputarkan teks proklamasi atau lagu Indonesia Raya, sehingga mohon berkenan Bapak Ibu untuk dapat menghentikan aktivitasnya sementara dan mendengarkan secara seksama ketika sedang diputarkan. Kami persilakan Bapak Ariel.
Thank you very much for the Mbak Putri giving me opportunity to, from this now on, I will chief this session. Good morning, everyone. Who attend offline here and also online. I see there are more 300 participants, you can say, during the from the online. First of all, in this morning, in this occasion, and I believe this is very rare opportunity to have Professor Takashi Asawa of Tokyo Tech to give a lecture, like technical assistance related to the very hot issues recently, I believe, in the building sector, how we utilize the building performance simulation, not only for building, but also for the neighborhood and also for the urban area. As introduction, can share the information of Professor Takashi Asawa. I will shortly introduce to all of you about this gentleman, this very prominent professor from Tokyo Tech. Ada ininya, CV-nya. I'm sorry, it seems still loading. So please correct me if I'm wrong, Asawa Sensei, particularly about yourself. Halo. Okay. Just before we start this session, so I heard that there's some mistake in affiliation of Professor Takashi Asawa. He is associate professor in Transdisciplinary Science and Building Engineering. Can say.
My main department is the Department of Architecture and Building Engineering.
Okay. Okay. So from Department of Architecture and the Built Environment, this is kind of the faculty of Transdisciplinary Science and Engineering from Tokyo Institute of Technology. As you may know that Tokyo Institute of Technology is one of the best universities in Japan. His field of specialization is urban and built environment, thermal environment, remote sensing, urban greening, and heat transfer simulation. So he's truly expert in the building simulation. His research interests include remote sensing of urban environment. Now he's trying to clarify the actual situation of urban heat island and clean by remote sensing observation from aircraft. And then also thermal environment simulation, detailed reproduction of urban areas and buildings of computers, and numerical simulation to clarify the characteristics of heat and airflow. Later on, Asawa Sensei will talk a lot about how he used the simulation to design the building and so on. The effect of relaxing green heat environment. He is focused on conduct research using various approaches, from experiments, actual measurements, to numerical analysis, and to the questions how can we plan buildings and cities cleaning out high. And passive design, conduct research from the viewpoint of environmental engineering about passive design that effectively controls air and heat inside and outside the building. Based on his track record, I believe he will share a lot with us about not only his experience, but also his knowledge in developing such a method, building performance methods, to design. Previously I also saw his wonderful design process of one of the main street in the Tokyo. That's wonderful, and I think we can learn a lot of this. Okay, without any further ado, so yeah, even though I will talk in English, so yeah, we also provide the interpreter. So you can hear what Asawa Sensei said in Bahasa Indonesia, in Indonesian, by clicking the interpretation on the screen, right? And if you have any questions, please do not hesitate. Even you use Bahasa Indonesia, I will try to translate, and also maybe the interpreter will translate and say to the Asawa Sensei. Yeah, but that's all, I think. And please, Asawa Sensei, time and also screen is yours for maximum 60 minutes. Onegaishimasu.
Okay. You can share. Share. Okay. Share first.
Please, can you on camera?
Camera. Something happened that
Malfunction.
no, it's a bit black now. I'm not sure why that's my camera.
As for your information, Sensei, the participant come across Indonesia. Yeah, from the PUPR. Thank you very much.
Okay. Good morning, everyone. Semara pagi. Pagi. This is Asawa.
Morning, Sensei.
Tokyo. Good morning. Selamat pagi. I'm very happy to be here and have share the very happy time with you and giving my experience and knowledge to share with you. And yes, I hope this time is fruitful, not only for you, but also for me. I want to learn from you this time. Thank you. So time is maybe limited, so I'd like to start my presentation titled The Simulation-Based Design for Built and Urban Environments. So in title, there is a design. Honestly say, I'm not designers. I'm scientist and engineers and researcher. So this means that I want to support design and collaborate with designers, architects, and how to achieve good and best design with the building and urban spaces with designers. So simulation-based means that we can offer them what is the best solution in view of the environment and how people feel comfort and can save energies. So I entitled this lecture Simulation-Based Design. And today's my agenda is three main topics: background and general idea. And target one is the residential houses with simulation-based design. And target two is urban spaces. So next, I'd like to talk that Tokyo is very hot. It's hotter than Bandung during summer season. So how to make a comfortable urban spaces is a very important issue in Japan, and how to use the spaces and how the people can release heat stress and with comfort. So urban space design are very important topics. So I want to explain that point at the third part. Okay, so let's begin at the first background and general idea. Firstly, that I'd like to simply compare the climatic condition between Indonesia and Japan. I know, I will understand that there are the many different climate zones in Indonesia, not only the one, but also the several climate regions. Yes, this time I experienced from the Surabaya, Tegal, and Bandung. So quite different, I see. We need to make the comfortable spaces and consider the energy saving strategies based on such a climatic regions. So this time I cannot compare the many cities, so only simply compare between Tokyo and Jakarta, very big mega cities. Okay, so Jakarta is a tropical monsoon climate in this Kepen climate classification map. And Tokyo is a humid subtropical climate. So this means the humid subtropical climate has the very hot summer. The broken line shows Tokyo's temperature and precipitations, and solid line is the Jakarta case, maximum and average and minimum temperature for each month. As you can see, in summer seasons, the temperature of Tokyo is very close, or sometimes reach over the Jakarta's temperature. So very, very hot and humid. The temperature, maximum temperature is over 30 or sometimes over 35 degrees Celsius, and humidity level is about 70 to 80%. So we have a very big similarities in such a hot and humid conditions. So I think that we can greatly share the information between Indonesia and Japan. So this is the reason why that I recently involved in the project of Indonesia. So how can we exchange data and knowledge between the cities and countries? Okay, so in view of urban environment, very large scales. So my one of my research field is remote sensing. How can we understand the actual condition of heat, summer environment in the cities and the surroundings from a satellite and aircraft, or sometimes using a helicopter? So you know what is this city in view of the heat environment? So this is Tokyo and nighttime for summer seasons. So you can see this red part is the center of Tokyo. This is the center of Tokyo. This is the Tokyo station around here. And then that you can see the central urbanized area of Tokyo is very hot during nighttime. We can easily understand from the satellite. Of course, the surrounding area is the reduced temperature. So this is called the urban heat island effect. This is also one of my research fields. So urban areas become hotter and hotter now. And also, I show you the data for comparing the temperature change from 19th to over recent years for about 100 years. So you can see the purple line. This is the result of Tokyo. I'm sorry that I cannot put the data of Indonesia here, and New York and Paris and Berlin. And this is the world's average temperature increase within 100 years. You can see the climate change, the global warming provide the temperature increase within 100 years, around 1 degree Celsius. But in case of Tokyo, the temperature increase is larger and larger. So this means that the temperature of Tokyo is 3 degrees Celsius hotter than the 100 years ago in average. So now we have a very hot environment. So we need to take care of such a things. So one of the general background and general ideas, how to consider such a heat problem and how to mitigate such a heat conditions, not only for the building itself, but also for the urban and the surrounding buildings by planting trees or something. Okay, so we the temperature of Tokyo is, of course, that largely dependent on the regional climate. So regional climate differ between the cities. Of course, Jakarta, Tokyo, or Jakarta and Bandung. So regional climate are largely differed among cities. So sometimes hot and sometimes bit cool. So if that there is a very hot conditions or a hot summer like Tokyo or Jakarta, so we need to mitigate the heat in outdoor spaces like this one by planting trees or providing air flow, wind, or something. So this is we call the control of microclimate. The surrounding environment is very important. So I feel the very very positive impression of Indonesian countries, especially in Bandung. So they have many trees and they can mitigate the heat or bring nice air. So this is a very what I feel ideal. I think ideal. So yes, you can already achieve this one. And second one is a building performance, building design and performance. So next that you need to consider how you bring such a fresh air into the building inside and how to keep the building performance for summer comfort of inside of buildings and also reduce energies. And finally, you can control the indoor environment, indoor temperature, humidity, such as things by mechanical equipment. So this 1 to 3 step is very important. So first two are called the passive techniques. In hot seasons, we call the passive cooling techniques. And third one is active techniques. So by using a mechanical equipment like air conditioning systems. So by considering these 1 to 2 steps in the design processes, yes, you can achieve the summer comfort with energy saving. So this means that please don't think first these active techniques. So please consider these passive techniques first. Then finally, that please consider apply these active techniques, and then that you can achieve the less energy. Okay, so this is the Japanese cases. So in traditional Japanese houses, originally equipped with such passive designs, natural ventilation and solar shading and evaporative cooling while sprinkling water in the outside to provide the coolness to the outside and inside. And also summer storage materials are just for example, the ground. The soils, they can store the coolness. We call this summer storage. And radiant cooling effect can be achieved by earth floor and earth wall. And also, finally, this is a very, very traditional Japanese lifestyle. We have a lifestyle and behavior that adapt to hot environment during summer seasons. Okay, so these sometimes we forget such a things, but yes, we can have a very nice traditions. Yeah, I understand the Indonesian situations almost similar. Yes, Indonesia have a very nice traditions and nice buildings and nice environment. So yes, we need to respect such a things. But now is we need to consider how should we now and how should we next. So not only think of the former years, but also now we need to understand the current situations and how we achieve such a passive designs to modern houses, contemporary houses, by combining them. But the important thing is the general, the idea and the principles. So solar shading by trees. Of course, this is what we need to consider first. So shading is important in hot environment and also bringing the comfort air from the outside. This is we call the comfort ventilations. Cross ventilation, stack ventilation can be applied even in the hot environment. And also during, if the outdoor temperature is over 30 or 35 degrees Celsius, and if the outdoor temperature is higher, yes, we can mitigate such a hot heat by evaporative cooling techniques, evaporative cooling. So water evaporation of water can remove a heat by latent heat, and that can provide the cool air into the indoor spaces. Yes, and during nighttime, yes, I can enjoy the very cool night last night with Ariel-san, and yes, this is very nice. So during nighttime, we can have a very lower nighttime temperature. So nighttime temperature, lower temperature can be stored into the building structures, materials, and something. So this is we call the cool storage or night purge. So if the building has such a thermal storage performances, yeah, we can store such a coolness to the next daytimes. So this means that if that outdoor temperature become higher, we can close the windows and that we can feel the coolness. But if that close windows and if you need to enjoy such a coolness, so thermal storage are needed. Okay, so these are the very general ideas of what we need to consider and what are the important point for thermal comfort with less energies by applying the passive cooling designs. Okay, so next point is the case studies in residential houses. So how apply the passive cooling techniques to Japanese traditional houses? So this is a collaboration researches with the housing company, Misa Homes. This is one of my collaboration partner in Japan. They also understand the Indonesian cases. This case study, of course, I have several case studies, and we collaborate with housing companies. But this is one of the very interesting the situations. The interesting situation is that this is the hottest cities in Japan, hottest. So how to adapt to such a hot environment is very, very big issues, and local government consider such a things. So they say that, yeah, this is the hottest cities, but one of the very comfortable cities, they say. So not hot is not the negative point. They change the mind that this is a positive point, how to mitigate it and attract people to this city. So several passive cooling techniques are applied not only the inside building itself, but also the outside. Water retaining pavements. So this is the sprayed water can absorb by the material, the road materials, and they provide evaporative cooling. And also passive cooling robots. So today the time is limited, so I cannot explain the details. So passive cooling robots, I will explain. Of course, I will explain later. Can spread the water on the robots by some of the techniques, then that can provide the very cool air into the outdoor, semi-outdoor space like a terrace and verandas, and also inside of the houses. And also the mist spray to provide the coolness to the space, and so on. Unfortunately, there are less trees. So this is one of the negative point of these areas. So I recommend the trees is important. So please provide the trees here, more trees. But there are the PV panels, photovoltaic, yes, power generation panels on the top, the roof. So they are afraid that the trees cover the PV panels. So they select the PVs for the energy generations. But I think this is a very big issue, how to combine them, trees and PVs in such a residential houses for the detached, especially for detached houses. And what we do is experiment at this house. Of course, that we discussed before the design stages. But after they build up these areas, we check how it works, how the performance can be achieved, and so on. So what we do is that compare some situations with passive cooling techniques and without passive cooling techniques, and how it cools the space, veranda terrace, or indoor spaces. And later, I will explain the simulation optimization by using simulations. But so the experiment and simulation is both very important. Not only the experiment, but also the simulation. Both combination are quite important. So firstly, check the performance of these passive cooling techniques in the one of these residential houses, and there is the passive cooling louvers and vegetations and screens like this one. In more you can easily understand the outdoor cooled air are coming into the indoor space, and the heated airs are removed from the top, the windows like this one. So how the window come from here and how it cools in the outdoor spaces and how it induced into the indoor spaces and how it removes released by such a high side windows or top windows. Okay, so this is passive cooling louvers developed by Mr. Holmes, and we check the performance at this site. Yes, you can see this is dry louver without watering, and this is the wet louvers, wet PC louvers. So water are dropped from the up top of these louvers, and then that they are go down by gravity, but they can smoothly spread the water on the louver surfaces. Then that all surfaces are fully cooled. You can see the temperature of these louvers are very close to wet bulb temperature. Wet bulb temperature is the how to say the minimum temperature that can be lowered by evaporation. So wet bulb temperature is to reach to the wet bulb temperature is a very important point by evaporation. And also this is the dry ones. Okay, so you can see the very big temperature differences between them. And also temperature, we check the different cases. I don't explain that in detail this time. So what we check is what is the difference in the temperature of the terrace and terrace space with the different louver positions, louver distance from the window to the louvers like this one, 1 meter and 2.8 meter, or what's the surrounding vegetations condition, fully surrounded by vegetations and half surrounded by vegetations, and also these, yes, these are the same, and no vegetations, how it changed without vegetations. And this is case 1, case 2 are cloudy day, and case 3 and case 4 are sunny days. Okay, so you can see that is when the louver is very close positions to the windows. The temperature of this terrace space is lowered by this passive cooling louvers. But this is yes, in case of this one, by surrounded by vegetations, yes, the temperature reduction can be achieved. Yes, temperature is cooled in semi-outdoor space. But as you can see, the cooled air is very heavy, so it go down and accumulated near the ground levels. So this is important. Cooled air is go down. And this is the same situations. And this is a sunny days. So there is a screen to shade, make a shade. But there is a heat coming from the screen, coming to the screen, and they reduce the cooling effect. This means that they heat this space. And also the long distance and heated by screen and no vegetation. So this is the worst case. So no cool can be obtained here. So it seems a very similar designs, louvers of vegetation and screens, but its performance is quite different. So we need to check such a very sensitive difference in the performance of the passive cooling effect. And also we also check the another situations like this one. So if that louver and window distance is very close, yes, it can go, cooled air go into the indoor space. But the louver and window position is far, around 2.8 meters. Yes, they don't reach because that cooled air go down. And heated by screens, yes, it's not good. So we understand such a design should affect the performances. So what is the best combination of them, and what is the best performance for the indoor thermal comfort? So there is a limitation in experiment and measurement. So there is a limited number of the sensors and limited number of the cost, a limited cost and time consuming or something. So in that case, the CFD computational simulation, like CFD simulation or energy simulation, is a very important techniques that can compensate the limitation of the experiment. Okay, and also the very powerful point of the simulation is that can apply to the optimization process, optimization of designs. So if you change the design of house or outdoor spaces and summer performances, okay, you can check which one is the best, most influential, and which are less influential, and then that you can get the best ones, best designs by using computer simulations. So in this process, we apply the optimum combination of passive cooling techniques and passive cooling designs for buildings by using simulations, like this one. And if you are knowledge of the CFD simulations, in many cases, the CFD is focusing on either of them for only the outdoor space or only indoor space. The indoor and outdoor are separated, completely separated. So this is a very general CFD simulation techniques. But as I explained, that we need to consider outdoor conditions and microclimate for indoor spaces. So we apply such a coupled approach for indoor and outdoors. So we can see the effect of outdoor space, trees or passive cooling louvers, and how it works for the indoor summer conditions and summer comfort. The coupled approach, but this is what we apply this time. And these are the calculation conditions. I don't explain too much in detail, but yes, we can have a very fine, very small grid to make the buildings to completely reproduce the design of the building and vegetation and so on in the computers. Okay, so, and I think that your question is, okay, so this simulation is accurate? Simulation is valid for to checking such a summer performance of buildings? So this is we call the validation process. Validation is this simulation is valid or not. So to the validation process, yeah, we can compare the measurement and simulations. Yes, as you can see in the validation process, see these are the temperature, vertical temperature distribution from the ground or from the floors to the ceiling or upside. Okay, so vertical temperature distribution for several points. So we check how the vertical temperature distribution change. As I explained before, the cooled air go down and hot air go up. So vertical temperature distribution is like this one. Higher in the upside and cooler in downside, bottom side, foot side. So this kind of the validation by using the vertical temperature distribution is very important. Okay, so we check the different points. As you can see, the black line is experiment, measurement, and orange line is simulation. Yes, you can see that there are very good agreement between them. Wind speed are a bit different, but this is okay. I understand what affects this result. The furniture layout is a bit different between the simulation and measurement. We cannot perfectly reproduce such a things in the furniture, the something inside of buildings, so there causes some differences. But yes, we understand that there is a good agreement. Okay, so this after doing such a validation process, yes, we can move to the optimization process. So what kind of the designs are the good, best, and optimized? Okay, so we have checked the louver window distance, as I explained, 1 meter, 1.8 meter, and 2.8 meter, which are the best. And also the surrounding vegetations, amount of surrounding vegetations, how they change or how it works. And later I will explain the ground and floor level. Ground floor level, the distance, the difference is also important because that cooled air go down. So ground and floor level. If there is a ground floor levels are bigger and bigger, yes, cooled air cannot go enter the indoor spaces. So this is very important. And also the design of the building, the facade walls, the wing wall, and the type of windows are also quite influential. As I explained later, I will explain later. Next, the window design and how the door of indoor open or close, such a conditions, and indoor furniture and partitions conditions, and so on. Yeah, I will try. These are the 20 cases we try, but today I will explain the some of them. Okay, I think that you can easily understand the by checking the these figures and the result. Okay, I show you the simulation result for each cases. First one is the original case, no change from the current designs. Okay, so you can see the this is the louvers and the vegetations, and here you can see the indoor spaces are a bit higher temperature this time, over the 28 degrees Celsius. This is I forget to explain that this is not the midsummer seasons, the late summer seasons. So I think outdoor temperature is sometimes reach to the 30 degrees and less than 30 degrees. But we can see that the temperature is how the temperature can be reduced by the passive cooling techniques. So in these seasons, it is quite important to apply the passive cooling techniques. So once the indoor are heated, they use air conditioning system. So of course, the very mid-summer seasons, we are largely dependent on air conditioning systems. This is very hottest cities. So in that cases, air conditioning is needed, but late summer seasons, yes, the condition of indoors and outdoor spaces largely affect the selection of windows open or using air conditioning. So very sensitive. So it is very important to apply the passive cooling technique. Okay. Anyway, in that case, as you can see, the cooled air are only coming here. So this is due to the very close the window to louver distance. So cooled air can be coming in. But as you can see, there is this louvers, the cooled air go this direction, No, doesn't go enter indoor spaces. Because this is the airflow, due to the airflow and long window to louver distance. Okay, so we change. So in that case, we change. We check the performance of wing wall. Wing wall is how to say that we call the wind capture. Don't go don't how to say the escape the wind cooled air window to the outside. So to catch at this point by walls and then straightly go to the indoor spaces through the windows. So, and also we change the door open conditions. This one, door open, and this one, entrance door open. So this, by using these conditions, as you can see, the cooled air go into the indoor spaces. Not only for this space, but also this space. Yes, cooled air go into this way. Okay, so this is better than the current situations. So next one is that we changed louver to window distance to 1.8 meters from 2.8 meters. Yes, you can see the cooled air are more achieved, shown in indoor spaces. And also next, we change the ground to floor level distance. Ground to floor level, originally it was a 0.4 meter, so it's a bit higher for the cooled air climb on the 0.4 meters. They cannot climb over to 0.84 meter. So we shorten the distance to 0.2 meter. Okay, so it can, cool air can go coming in. Only the very small change in the design. Ground to floor levels distance, they provide a more cooled air inside. Yes, this is the, and also we change the window designs. Originally, we applied the sliding window. So sliding window is always half open. Maximum is, maximum half open. So to fully open, 100% open the windows, we apply this kind of the double casement window. So both sides of window are fully open. Okay, so 100% window can be captured. Okay, as you can see, the fully cooled. Then finally, to achieve more cool air, so yes, we move the louver to close the windows. But this is not, may not be recommended in actual situations because the louver is too close to the window, so they cannot enjoy the terrace space. Okay, so this is a, yes, that S10 is, and also this S10, we, of course, we check the thermal comfort of indoor spaces, how the people can be achieve the thermal comfort. As you can see, the indoor air temperature can be reduced from the 1.2 to 1.6 degrees Celsius from the original case to the final case. 1.2 to 1.6 degree is cooler. But what is surprising is the thermal comfort. Thermal comfort, can reduce the reduction of SET star is minus 2.5 degrees Celsius. So thermal comfort index SET star is the index that people can feel the coolness by the air temperature and humidity or wind speed and radiation. The totally people feel can coolness 2.5 degree than the original case. So by the, as you can see, the easily understand from these two cases. Of course, so this is a final, we think that optimum case for the passive cooling design. But I explained that this 1 meter, the distance of louver is maybe too short for actual use of outdoor spaces. So this is a discussion with designers of which is the best. So you select the more performance on thermal environment, thermal comfort, or you select the more, the wide space in outdoor space. So this is also, if we show this result to residents, okay, residents can understand, oh, this position is okay, this position is not okay. Yes, but we need to show the evidence to they can understand which is more suitable for them in their lifestyle and their comfort. But there is now no evidence or data that can be shown them. So now if once we can show them, yes, we can select best one for them. And also we apply this kind of the simulation in more larger scales in outdoor spaces with Mr. Holmes. Hirayama-san is previously the Mr. Holmes, the researcher in research R&D center of Mr. Holmes, but she is now the professor of Kogakuin University, and she is one of the colleagues of our project. Yes, she conducted more larger scales, the airflow and temperature simulations, and how the window goes through the low between the houses and what is the layout of a building is the best or not. Not only the building itself, but also the residential area, the district scales, or some performances. And also in outdoor spaces, yes, we can check. Later I will show this. I will explain that this simulation tools in outdoor spaces. For example, the what kind of layout of passive cooling louvers are more provide the coolness in outdoor spaces by using such a district scale, the larger scale simulation tools, not only the single buildings. And also the mean radiant temperature is one of the index that for the radiation environment, summer radiation environment. Summer radiation is very important for summer comfort, how it can be reduced by such a passive cooling louvers and air temperature, how it changed, and finally the summer comfort index, how it can be reduced by outdoor space designs, passive cooling techniques. Yes, finally that, yes, this simulation is conducted for the summer seasons. So as you remember that this is the hottest cities, the outdoor spaces open space use is less and less due to the hotter and hotter in outdoor spaces. But providing such a passive cooling techniques, this SET star from 30 to 32.5 degrees Celsius is the summary acceptable range, not reach to the summer comfort. People cannot feel fully comfort, but this is also accept. So yes, by using the numerical simulations, we can understand the indoor summer comfort and building design, and also outdoor designs. So this means that what I entitled in this lecture, simulation-based design. But yes, what I need to tell you now is that, but what the designers and housing makers select is this one, one-sided. Because in view of summer performances, yes, we think that this one is best. With this is best. But it is too much enclosed for the residents, so one-sided is selected. So, but this is a discussion, so no problem. But we can provide such evidence and data. Okay, finally, that I'd like to explain the larger scales, urban environment, urban summer environment. I think that this is a bit more close to the governmental and official public the works, how the building, how the urban spaces, related to urban planning and urban design, and so on, and landscape design, and so on. Okay, so we also develop the system. We also develop a system that can check the summer performances and summer comfort of such a urban district scales by using 3D modeling techniques and simulations. Okay, so firstly, that 3D modeling of urban district and summer environment simulation will be talked. Okay, so there are the different types of the simulation techniques, like the surface temperature and the radiation environment simulation. So this is one of the simulation techniques. Surface temperature, the ground temperature and building wall temperature and the roof temperature. So these are the very important information for the summer comfort of outdoor spaces. So heated or cooled or shaded by trees and ground temperature, how it affects the human summer stress and human summer comfort. There is a research that very higher surface temperature areas, this means that very bad summer radiation conditions cause the heat stroke. So in Japan, during summer season, heat stress is a very important, very big issues, especially for elderly people. Yes, so in view of such a heat stroke and heat stress, summer surface temperature and radiation environment. Thermal radiation environment is very important. And also airflow and air temperature, as I explained, is also other techniques, and energy use, building energy use. Of course, there are and finally that we can combine them. But there are the three large category of the simulations in urban and district scales. Okay, but today time is limited. I mainly focus on this first part. So 3D modeling, what we do is that we apply the 3D modeling, 3D CAD is the 3D modeling the system for the building and urban spaces. So by using 3D modeling, that we can change the designs of building and materials and change the greens, the designs and green species, and how it changed the thermal environment, especially for surface temperature, can be simulated. Yes, this simulation can be performed on this kind of the laptop computers, and then that we can check, understand how the design of buildings and trees change the surface temperature and so on. Yes, computer-aided design, CAD, is very popular, I think, in Indonesia. So this, by using a computational aided design, CAD, yeah, we can do this in the design stages, planning stages. Yes, as you can see, the solar, how the buildings, walls and roofs receive the direct solar radiation and sky solar radiation. You have sky solar radiation and reflected solar radiation, and exchange a long wave radiation with the sky and surroundings. So these are the radiation exchange can be totally simulated by these simulation models with 3D buildings. Yes, we can extend this simulation to the district scale like this one. So this is the one with the middle size or maybe a bit smaller size, the cities. By using a 3D CAD models like this one. And also we put the materials. The materials are also very necessary to simulate the building performance, of course, building performance and thermal environment of urban spaces, the roof materials and wall materials, the glass and so on, ground and something. So these materials can be put to the simulation model, and then that, yes, you can see the surface temperature of the urban district scales. So summer seasons and winter seasons. As you can see, that there is a high-rise buildings, and they provide the shades to the surroundings and difference in the surface temperature between the roof materials, and there are the parks. So the parks, how they provide the shade and cool the surface temperature of the area. Okay, so you can see the surface temperature differences, distributions by using these simulation models. Okay, do you remember that? So for simulations, the validation is important, validation. So how to validate this simulation result in district scales? Yes, we use the remote sensing data from airplane. Yeah, we fly the airplane with some cameras, then that we check the surface temperature from the aircraft from the 500 meters. Like this one, this is a city, this is central city areas, and also this is a land cover map obtained by the remote sensing. Remote sensing is a, yes, camera, there is a camera sensors, and also some cameras, they can completely check the thermal conditions and some surface materials and so on from the 500 meters. So resolution means that what is the how is the details of the each buildings and ground materials is that around 0.6 meter resolution. So this is enough resolution. Resolution is how that we can check the details of the ground levels and building shapes and so on. It's 0.6 meters. And we conducted the remote sensing observation for daytime and evening time. Okay, so we compared them, remote sensing observation and numerical simulations. So you can see the shade, effect of shade and building, the surface temperature and the difference in the surface temperature between them, between building types and so on, can be not perfectly, but enough accurately reproduced. So we select the over 100 points to check the surface temperature between the remote sensing and experiment numerical simulations. Yes, you can see that there are the very big correlation, good correlation between them. And also this is the winter cases. Yes, there is a shade here by, this is a high-rise building. So there is a very big shade here. And also this is a simulation, also can be reproduced such a shading effect by these big trees, big buildings, tall buildings. Yes, we can understand these are the quite nice performance in simulations. So there is a very good correlation between them. Okay, so we can validate it for such a simulation result. Yes, we conducted for the summer and winter seasons to check this difference between the simulation and the actual conditions by remote sensing techniques. Okay, so we focus, yes, we can simulate the full area of urban district from the central areas and parks and commercialized areas or residential areas. So now I pick up the one of the residential areas, this one. And now I pick up only here. Okay, so this is the current, this simulation result of the current situations. Now, there is the roofs and these are the parking lots. This is a simulation result of the summer daytime around noon. So, and hot seasons, air temperature is about 33 degrees Celsius. Yes, very hot condition. As you can see, the surface temperature of the roofs of the residential houses is very higher. And also, yes, you can see the asphalt pavement. So these are the provided for parking lot is also higher. Okay, so what is the effectiveness of what is the powerful point is that we can change the designs of this urban district. How to change is that, for example, if you want to understand the effect of trees or how to consider the effect of materials, of historical materials or more modern materials or something, or how to provide the channel, like this one channel is one of the, how to say, the historical heritage of this area, but now originally covered this, the stream. Stream is a water stream is covered, but how it change if you open this stream heritage, or what is that? How to apply the more low environmental load, low energy and low environmental load buildings. So how it works can be simulated. Okay, so this is one of the image. I cannot see. I'm sorry, I cannot put the button. Okay, I skipped this one. Okay, so if you change, this is just, now I can make, okay. Now I stop the laser pointer. If that I use a laser pointer, I cannot push this button. Okay, now it's okay. Now it's okay. So now how it changes how it happens when we produce a more good design with trees and make the open space more comfortable, not the parking lots, but you provide the more, how to say, the useful and comfortable outdoor open spaces with a channel stream, the water stream and the greens and so on. So by using 3D CAD systems, yes, we can do in design, in view, townscape, and view the design of buildings. The important is that we can check the performance in the view of summer environment and summer comfort. Yes, summer, how it changed, how it calls the summer environment. So if that you achieve in the future image in 2050, like this one, honestly say, this is only the image, not the, we can achieve this one until now. But what I need to say is that we can share the image of future what is change, or how to change these areas, or how to keep, how to prevent, how to preserve the current heritage and current the cultures and current urban areas, and what is the what is the preserve and what is the changed or something. And then that thermal environment can be also simulated by using simulation. How it works for thermal environment or thermal comfort. Yes, for example, parking lots current. Yes, I don't deny the parking lots. Of course, it's important, but this area is less and less people now. So too much parking lots is not needed. So most urban spaces can be provided for comfort of people. But this is just very general parking, pocket park in Japan, like this one, with grass and so, but no big trees. No, big trees are not so popular in Japan compared to Indonesia. But yes, I love big trees and good shading and good environment for people with trees. Green designs, yes, you can provide these areas like this one, and how it change the summer condition, summer environment. This is the index of mean radiant temperature, summer radiation index. Of course, we can calculate the summer comfort, as I explained before. Oh, yes, the summer comfort can be dramatically changed from the hot environment to cool environment. Yes, so by not only the changing the design, but also changing the performance of the space. And also the PV panels can be put on the rooftop if how it can provide the energies to each buildings. Yes, as I explained, the layout of PV panels and greens are very difficult problems. So we check how it works, how to put the roof, trees and PV panels not to cover over the PV panels by greens like this one, not to make a shade on PV panels, but make a shade to the open space and street space. And also we check the performance of building. Sorry, the performance. Sorry, I forget to put the one slide. Sorry, but I check the how change the building. So this is a bit old building. So how to change the building materials and how to what is the effect of the changing a building materials, adding the insulation and also the changing the building equipment, air conditioning system, and lighting, and hot water supply, and kitchen appliances, and so on. And finally, that we can check the effect of outdoor spaces and the effect of building performance and the effect of building equipment on the energy consumption, like this one. So finally, that we can achieve that 83% reduction by combination of them, outdoor space and building performance, and also the building equipment. So this is just completed in the simulations. Okay, so as you can understand the building, now we can connect the building design and outdoor space design and performance of buildings in view of comfort and energies. And also, time is a bit limited. So final part is now I joined the current project I joined in actual project. So application of this kind of the simulation to urban space design with summer comfort. I already told the Ariel-san this project. Marunouchi Street Park is a very interesting project in Japan, very attractive project in Japan. So what is the attractive point is that this urban street park is not the original park. So this is a street in the current days, in the general days, normal days. But during event for summer season, it closed shut down all the cars, and then that provides open space tentatively. So this is like this one. So put the greens, lawns on the ground, and put the bench and desk here, and to provide the good open spaces. So what is surprising is not the suburban areas, but this is the center of Tokyo. In front of Tokyo Station, there is like this one space, not to provide for the pedestrians and office workers who can enjoy this one, and shopping persons who enjoy this one space, and the children, yes, they can enjoy here for open spaces. Like this one, this is a Tokyo station. In front of Tokyo station, there is a street. So this street is provided to the comfort open spaces during summer season. So we check how. So this is this event is conducted during summer season. So we check that. Okay, so what is summer comfort and how to achieve summer comfort by passive cooling techniques by using the measurement and simulation. So I don't explain too much today with the limited time, but we check the summer performances by using this kind of the thermography, very special thermography developed by our laboratory. So you can see the summer performance of the buildings and urban spaces can be checked by in view of some surface temperatures. As you can see, as I explained before, the surface temperature is very important. So this surface temperature, the 360-degree surface temperature for surface temperature of this area can be captured by this system. Okay, we check the performance summer conditions for each the spaces like this one. So this is only the one parasol, only one parasol shading, but this is not enough. Okay, so this is not good. So next, we remove this one. Okay, next change, next one. So I mean that I'm, as I explained, I'm not the designers and I'm not planners. So the decision is them, but we can provide the data. Okay, this is not good, yes. So they don't select this one. Trees is okay. So surface temperature is lower and can be provide the coolness. And also, yeah, this is the most good point. Yes, here, very good tree crowns, the canopies, and also provide there is a lawn grasses, or sometimes provide the water retaining pavement, evaporation, the evaporated material. Okay, we can make a coolness here. And also simulations. Okay, we can check the effect of the different designs and different passive cooling items on the surface temperature and summer comfort. So as I explained, passive cooling louvers or water retentive pavement and shading devices or membrane roofs. So shading devices, how it works. The wind speed and air temperature and mean radiant temperature and the surface temperature, standard new effective temperature, summer comfort, as you can see. So this is the present case, and this is applying the passive cooling techniques, like as I explained. Yes, so we can achieve, by applying them, yeah, we can achieve the summer comfort here. Okay, so this is not the very stressful to people, and they can achieve the summer comfort even in very hot summer seasons, Because the Japanese summer is very hot and hotter. Now, this year, the surface air temperature is about over 35 degrees Celsius in maximum. So this is a very hot conditions, but people can use this space with comfort. So the management company of this area and local government decide to increase the furnitures and desk or something to provide the good spaces because that they can feel coolness. So this can enough for their resting and working or playing the ping pong or something, and also good sleep. So this is not the tradition in Japan. So traditional Japanese people don't use too much on the outdoor spaces. But now that we can use this space, because after pandemic that with Corona, that we need to use more outdoor open spaces with fresh airs. And we can release the stress for the very hard working. So at this time, kind of the spaces. Okay, so finally that we check how by questionnaire how people feel comfort or cool on the space. So during hot seasons, yeah, people can feel the cool and slightly cool in this space, and also slightly comfortable in this space. So this is just we make a questionnaire here, and 80% of people can feel the coolness and over 80% people use this space can feel comfortable. So this is very important. If that once you provide such a furniture or desks or something across the street and provide the spaces, but if they don't use the space, it's too much cost and effort, time consuming. So we need to decide that this is okay or not. For the people use space, yes, so this is okay. So we can use this space and we can utilize more for this space. So the design are changed year by year and better and better now. Yes, I think this is the final slide. For numerical simulations, now Japanese the government also consider such a situation of application of the numerical simulation of something, numerical simulation, or how to say, the evaluate the energy or structure or the more, how to say, the transportation systems based on the 3D models. So this is a very now attractive project provided by Japanese government, Minister of Land Infrastructure and Transport and Tourism. So this is a total 3D model of the Japan. So this is open data, and we can use this data. So honestly say, previously we make that model, 3D model of areas by ourselves. So it takes my student very hard work and make models. So it's not needed now, from now, because that they originally provide a 3D model, totally 3D model of urban center of urban Tokyo or suburban areas or other cities like this one, and utilize to some simulation models. Yes, now we apply this open 3D models to the simulations now. But now is a very simple model we apply. But now Japanese, the government increase the building designs like this one. Lot 1 is a very simple model, and lot 4 is a very detailed model. So if they can provide a more detailed data, yes, we can use them for simulation, not only the surface thermal conditions, thermal environment, but also the energy simulations. Yes. So this is the, I think, near future we can do this one. Okay, I skip them. Its time is over. Okay. So I think this is 60 minutes for my presentation time. So today I talked about these topics. So these are today I provided is one of my research and my, how to say, the trial collaborate with company and government, local government and government to achieve such a thermal comfort and less energy uses by using simulations. Yes. So, but now is in progress now. So 100% we can achieve in the practical phase. So this is 50% is just research phase now, and 50% is the practical phase. So how to achieve this kind of the simulation-based design in the practical phase, practical the situations, collaborate with designers and local government people. Stakeholders is, I think, that very important next step. So I want to discuss with you at this time also. Okay, so I'm sorry for the over time of my talk. So that's finished from me. These are the acknowledgement with the collaborator and researchers, my colleagues. So thank you very much for your listening. Terima kasih.
はい、ありがとうございます、Asawa Sensei. Thank you very much for your very insightful presentation, and I think now we can understand why Japan and Japanese can achieve kind of a better thermal, better environment, because they use data, they use tools before making decision. How to change, how to design, how to everything. So I think that's one of the most important to be reflected in Indonesia if we want to achieve more sustainable neighborhood, sustainable urban. So I think we should consider about the data, about the tools and so on. Yeah, actually I write down some notes, but this is not my turn yet to summarize. So I think I see some questions in the chat room. So, but before that, and I don't know, maybe in YouTube also there are some questions, but before that, I will invite some participants, not only maybe in this room offline, but also in the Zoom room, also possible to raise hand and ask directly to the Asawa Sensei. Maybe from this room first. Oh, your students coming here, Sensei. Emerson. Yeah. Okay. Before question, I would like to greet our former colleague, not our colleague, but former in Bandung, Mr. Johnny Subrata-san. He's very fluent in speaking Japanese. Pak Johnny Subrata, can you hear me? Or maybe you want to say something? Okay, I think I miss him. Okay, if you have any questions, please raise your hand. Pak Nuk, Pak Pepen, or maybe Emir, you have questions? Okay. Oh my God, the student asked the professor.
Good morning, Asawa Sensei, Hajime Mashite. My name is Emir. I want to ask about the Misawa Home project at Saitama Prefecture. I think it is very interesting. And I want to ask if it is the Misawa Homes, do Sensei research also the occupant survey? Do they feel comfortable or not based on the survey? And then Misawa Home uses many passive techniques. Then do they use active as well? Maybe a air conditioner or ceiling fan to manage the deficit comfortable temperature? And then how about the energy consumption of the Misawa Homes? And so do they reduce the energy consumption or not? Thank you very much.
Okay, Emil-san, thank you for your good questions. Good questions. So that is what I cannot explain in detail within this 1 hour. Yes, firstly, that Misawa Homes conduct many things, checking the data or something for energy consumption, or occupants' satisfaction or thermal comfort, or how the air conditioners and fans or such facilities can work well, and how they can be combined with passive cooling techniques. So this is what the Misawa Home do now. So I think the next time that you can invite the Hirayama Sensei, maybe she's very understands such point. Yes, maybe more than me. Anyway, so they check the energy consumption by a home energy management system, and they also provide that data to the residents. So this is also the residents can understand how they use the energies and how to reduce the energies by themselves by checking the data, and also many sensors for the temperature on energy consumption, or the wind weather stations. They provide the information to residents. So now is a very nice temperature and no rains predictions, so you can open the windows, and also people can check such information from smartphones and monitors. Yes, they can decide the behavior, and if that the temperature is too much higher, not only they feel by themselves, but the sensors, yes, they can use across the windows, and they can, of course, select the air conditioning system. Totally the energy consumption, they say that can be reduced. I'm sorry that I don't have enough data, actual data, and people can satisfy that things. And satisfaction can be achieved by the people can select the many ways by themselves. Open windows and air conditioning use or something. So, but the people can, current problem is that people cannot have enough data or something that such a information to them for that by selecting by themselves. Now that there are many too much equipment, too much the techniques for something, so they cannot select all. So they need to the data, providing the data easily that they can understand, and that can easier the transfer of the such a knowledge and data to the residents can make their life and the decision better for reducing energies and also increasing their quality of life. So they check such a things. So I think next time, please invite them. I recommend her. It's a very nice, attractive point. Yes, thank you, Emily-san. Good question.
Thank you very much, Asawa Sensei. I think that can be possible for his research topic during his study in Japan. Okay. Yeah. Is there any questions? Okay. Pak Andri, please say it shortly.
Yes. Thank you very much for the chance. Yeah, it was very nice presentation, Asawa Sensei. But you know that I saw your presentation, and this is very nice. And then you explain only about the dropping temperature in the situation during the summer, outdoor or indoor in the building. But I'm very curious about the standard of the comfortable range for the Japanese during the summer. Do you have maybe some data about this information? Maybe you can share to us. Thank you very much.
Thank you. Before you answer the questions, Asawa Sensei, so I would like to remind all the participants, including in the Zoom meeting. So I think it is better if you speak directly to ask questions to Asawa Sensei. I saw some very interesting questions. So if possible, please talk and ask directly by yourself to Asawa Sensei. Thank you very much. So please, Asawa Sensei.
Yes, in the Japanese summer is a bit how to say that there are the 4 months. 4 months is during summer seasons from the June, July, August, and September. So it a bit changed this summer conditions for you. July is a very humid, very humid with the rainy days, like the rainy season of Indonesia, and the July to August is a very hot season, and September is a bit late. The summer, as I today explained, so that depends. So we can check such a weather condition and the temperature and the humidity levels and precipitation for each the months or each time period, even within the summer season, and then that we select the appropriate passive cooling techniques even within the summer seasons for the more humid. Okay, no evaporation or something. Yeah. So, and also during midsummer season, it of course, the air conditioning system is needed. So how the passive cooling techniques can support such air conditioning systems, and also but late summer season is just we can encourage the passive cooling techniques, opening the windows and provide the outdoor fresh air or something. So that depends on the such a temperature and outdoor the conditions of summer. So that, as you say, that there are depend on such a weather data, and I want to explain such a how it changes in the data with data and how it affect the summer performance or summer comfort, and also selection of the each techniques. Yes, it's okay. Okay.
Thank you very much, Asawa Sensei. So I'd like to invite some participants from the Zoom meeting. So previously I saw Pak Rusli raise his hand, and then let's collect all the questions, or not all, maybe 3 questions at the first term. So I'd like to invite Pak Rusli from Dirjen Perumahan ya, from Perumahan. And then, okay, and then after Pak Rusli, I invite, I don't know, this is Cornelius Ardianto, is Miss or Mister? And then Inatan, oh, he is absent, she is absent. So maybe after Pak Cornelius, probably, yeah. And then I will, I'd like to invite Lee Hendry, Bapak atau Ibu Lee Hendry. Please, if you want to say your questions in Bahasa Indonesia, also possible. Thank you very much. Please, Pak Rusli.
Terima kasih, Pak Ariel. Selamat siang.
Selamat siang, Pak Rusli.
Profesor. Sensei, selamat siang. Gini, Pak Ariel, mungkin saya bahasa Indonesia aja ya. Gimana suara saya jelas, Pak?
Jelas sekali, Pak.
Oh, ya.
Wah, menggelegar,
Ini,
Pak Rusli.
Kami kan sering bangun rusun gitu ya, terutama di daerah panas gitu. Nah, saya lihat kita itu sering kan kita bangun itu rumah itu untuk yang kalangan menengah bawah ya, MBR ya. Nah, itu salah satu kan itu adalah kita memang menghindari namanya penggunaan AC ataupun ya, karena supaya bangunan itu murah perawatan maupun pembangunannya. Nah, di sini kalau kadang-kadang kita kendala itu kita kan umumnya menggunakan bahan yang konvensional ya, dindingnya kadang bata, terus juga kadang-kadang bata ringan. Nah, itu saya lihat memang faktor panasnya itu adalah terutama di suhu yang panas ya, itu adalah dari panas materialnya sendiri, panas dindingnya sendiri, dinding atap gitu, yang agak lama memang tinggal di ruangan itu, pengaruh dari atap, dinding semua, karena mungkin pengaruh sinar matahari mulai dari pagi sampai sore. Nah, itu kadang-kadang pelepasan energinya itu kadang-kadang sampai semalam pun itu masih terasa panas, walaupun sudah malam kan si dinding itu atau atap pun dia masih menyimpan panas ya, sehingga tetap ruangan itu terasa panas, tidak cepat keluar, tidak cepat dingin. Nah, barangkali mohon saran, ada gak bahan yang tidak bisa menolak panas, misalnya gimana ya? Artinya bagaimana supaya partisinya itu tidak cepat menyimpan panas, sehingga kenyamanan di penghuninya itu lebih nyaman gitu, tapi dengan biaya murah gitu. Seperti umumnya kita dinding konvensional kan biayanya murah ya, bata ringan. Barangkali intinya gitu aja, Pak Ariel. Makasih.
Baik, Pak Rusli, terima kasih. We got your points, and I will interpret to the Asawa Sensei. Now I invite Pak siapa tadi? I invite Pak Cornelius Ardian. Ya, please, Pak Cornelius. Halo.
Ya. Apakah suara saya terdengar?
Ya, sangat jelas, Pak. Please, you can ask directly.
Terima kasih. Mohon izin saya menggunakan bahasa Indonesia. Yang saya hormati Bapak Profesor dan juga Bapak Ibu sekalian peserta Bintek. Di sini saya ingin bertanya. Tadi disampaikan bahwa salah satu cara untuk menciptakan istilahnya kenyamanan thermal itu ada yang menggunakan mist spray. Nah, pertanyaan saya, apakah misal di suatu kondisi di sebuah koridor lah, katakanlah koridor dengan dia itu kecepatan angin yang rendah, jadi anginnya sedikit, kemudian tingkat kelembapannya tinggi, tapi di sini tuh di koridor itu juga suhunya panas gitu. Nah, apakah mist spray ini akan efektif bila digunakan sebagai sebuah intervensi dalam rangka menciptakan kenyamanan thermal? Apakah si air dari mist spray atau water spray itu apakah tidak justru nanti meningkatkan kelembapan tingkat kelembapannya humidity-nya. Mungkin itu saja, Pak.
Thank you very much, Pak Ardianto. And the last, I invite Lee Henry, please.
Okay, thank you for the time and the opportunity. I will use bahasa instead. Okay. Dalam paparan yang di awal sekali bagian pertama ya, saya melihat cukup menarik terkait dengan sebelumnya saya konfirmasi apakah suara saya bisa didengar.
Sangat jelas sekali.
Oke, baik, terima kasih. Di paparan yang pertama saya memahami bahwa passive cooling ini terdiri dari berbagai mengkombinasikan berbagai macam konsep seperti tadi ventilasinya menggunakan crosswind, terus ada pengaruh vegetasi yang mendinginkan ambient temperatur tadi ya, sama ada wind catcher juga. Nah di sini yang tertarik yang mungkin berbeda itu di aplikasi di beberapa proyek kita, yaitu penggunaan kisi-kisi ini. Dan tadi dipaparkan kisi-kisi basah ini yang saya pahami penurunan temperaturnya cukup baik seperti itu. Nah, yang ingin saya tanyakan bagaimana penerapannya seperti itu sehingga tetap menjaga kisi-kisi ini tetap basah. Pastinya kan tidak secara manual disiram dengan air seperti itu. Kemudian terkait dengan materialnya, apakah lebih efisien yang berbahan metal seperti aluminium atau kayu, atau mungkin tadi ada PC ya, polikarbonat seperti itu tadi disampaikan. Demikian pertanyaan saya. Thank you very much.
Okay, thank you very much, Bapak dan Ibu. We got the point. So, Asawa Sensei, there are 3 questions for you from Pak Rusli. He was head of Balai. Balai is like the agency that responsible to construct the rusun in some place, in particular place. Yeah, he had a lot of experience in constructing the rusun for the low and middle people, low middle income people, and particularly for low income people. Yeah, one of the problem he faces that the heat source during and particularly during the night times come from the building material itself, from the wall, from the roof, and so on. He store the heat during the daytime and then emit during the nighttime. So yeah, perhaps he needs your advice. How to prevent this kind of thing is not happen. I mean, how to prevent heat storage in the building materials and then emit it into the indoor space during the nighttime. That is the first questions. The materials, they use conventional materials because of the cost restriction, cost constraints. And the second is, the questions from Pak Cornelius, exactly about the, as you may know that Indonesia is very hot and humid, right? So sometimes if we use like the mist spray, that will increase the humidity itself, and then and sometimes it reaches saturated point. And yeah, do you think it is efficient and effective in case of Indonesia, for example? Because we need less humid in order to absorb more heat if we use the mist spray. And and the last questions about the louver itself. I think so many people in here interesting about the passive cooling louver. So basically, he asked about how exactly it works. Just maybe same as my questions, because as you may know that this is based on the wet louver, right? So we have to give water continuously, and in order to absorb heat as much as possible. And it is indeed impossible to do it manually. We spray by ourselves, but I think there's some machinery working in the louver. And the second question from him is, which material is more effective to reduce temperature, aluminum, polycarbonate, or maybe some wooden materials? There are 3 questions for you.
Question for the building.
Yeah, no, for the material of louver. Yeah, Pak Li, material louvernya ya?
Yes, material louvernya yang terbaik, yang the most effective
and
material
efficient, right?
to be used.
We got it. Yeah.
Okay, thank you very much for your valuable comments and questions. Yes, for the first questions, for the heat absorption of lucerne into the materials during the daytime and it keeps nighttime is one of the big issues of the thermal storage effect, heat storage effect of the materials in lucerne. So the reason why that the heat absorbed by the materials and the structures of lucerne during daytime is the solar heat energies that come from the windows and come through the walls and roofs. So it can be absorbed by the walls and roofs and floors during daytime, and that is that continue to the nighttime. So this is the one big issues for the materials that has a heat capacity, thermal storage. So to prevent such things, I think one is to make enough shade to not to enter the solar heat from the outside. And second one is to prevent the heat passing through the walls by the heat transmission, thermal transmissions, by preventing, yes, of course, one of the important method is the insulation on the external side. This is an effective, yes, insulation as external side. Of course, that this is maybe some the cost issues. Of course, I understand. And also, third one is the dissipate such a thermal heat storage during daytime is, as I explained, the nighttime cooling. So to provide the nighttime airs into the building inside, or through the windows and something, and through the floors, and then dissipate remove the heat on the heated during daytime. So this is what we are trying to apply in Indonesia at the experimental house to remove the heat with the cooler outdoor air. Okay, so this is my answer is now the technical and principal reason. So yes, is it the cost competitive or something? Is of course the discussions. Yes, in the we need to understand the principles, what is effective and what is not effective, and then that how we select in the real application, the practical to listen. So this is my answer to first questions. Is okay. Second one is the mist. Yes, mist spray and evaporative cooling. Yes, is it effective in hot and humid or in Indonesia or not? In my yes, I think that in my experience and in my measurement, if that outdoor temperature is less than 70%, hopefully 60%, less than 70%, and hopefully 60% is okay for such a evaporation of water by mist or something. Humidity, yeah, 60%, sorry, 60%, and maximum 70%. If that relative humidity level is about 70%, the temperature is higher, then that we have a potential of evaporation, and then that we can feel the coolness. But above 70%, it's not okay, not good. Yeah, too humid. So, yes, 70%. So, as that case, so as a condition, we cannot select the over 70% is not effective. So yes, that's okay. So, but in Japan, it's in Japanese situations, the relative humidity is about 60% in maximum in summer season, 60%. So it's okay in Japan. So Yes, this means that in Indonesia, this may not be recommended. Yes, okay. And also third question is material for the Ruba, passive cooling Ruba, and also way of how it works for the evaporation, what is the mechanism and so on. I'm sorry now that my computer is disconnected from Wi-Fi and I cannot now show the images and so on. And the mechanism of passive cooling Ruba is that the Ruba surface is coated by the very special materials called the photocatalyst. What is a photocatalyst? Is that photocatalyst can to have how to say the performance that can smoothly spread the water on the surfaces. So if you put the water on the surface, the water will this kind of the drop, the dot. So this is not enough to fully spread the water on the surfaces, but by using a photocatalyst, it react with the spreading with the UV, ultraviolet radiation in the solar radiation, so it can smoothly spread all surfaces. Yes, so this is one of the very big, important techniques for the Rubas, and then that it can provide the cooling, the evaporative cooling on the Ruba surfaces. And provided water was the tap water. So the pressure of tap water is sometimes enough pressure of tap water on the watering system, and sometimes we use the electrical pump, but a very small pump, very small pump, not so electric consuming, and also the very small amount of the water then that evaporate. So this is the system. And the material is now the Mr. Holmes select the aluminum. Very easier to construct and easier to spread the water and easier to maintain. So now they finally select aluminum. Yeah.
Thank you very much.
Thank you.
Bapak Ibu yang bertanya tadi sudah ini ya, ada interpreternya tadi ya, sudah dijelaskan ya. Ya saya pikir sudah. Jadi menarik karena ternyata dia pakai fotokatalis. Jadi begitu material louvernya itu dilapisi dengan fotokatalis, begitu dia kena UV, dia akan merangsang apa namanya, mendorong airnya yang diteteskan itu akan menyebar sehingga dia luasan bidang permukaannya semakin kecil sehingga dia cepat menyerap panas sehingga udara sekitarnya jadi dingin. Itu prinsipnya Bapak yang bertanya tadi ya. Dan aluminium itu yang jadi akhirnya aluminium is the more efficient and effective in terms of materials for the louver. Thank you very much, Asawa Sensei. Okay, now we move to the next questions. Mas Evan, do you have any questions? Pak Jun, you have questions? Okay. I think I should invite in YouTube. Is there any questions? I invite directly for this is one simple questions from one of the participants, Yulia Hastuti. Nama program, name of the software you use for simulation. Maybe Stream we already know, but I think she interested in other software for other software. And let's gather the questions. Pak Krishna dari SSPIP, please, if you have a questions, your questions is also interesting. Maybe we can get some insight from Asawa Sensei and Pak Gulam Shah.
Ya, selamat siang. Ya. Saya Krishna dari SSPIP mau menanyakan untuk pertanyaan saya untuk di pemukiman kan biasanya menggunakan aspal atau konkrit ya. Nah, apakah untuk material baru seperti geopori aspal bisa dipergunakan di area Jakarta?
Oke.
Jadi untuk resapan airnya lebih maksimal daripada menggunakan aspal dan konkrit yang sekarang ini.
Baik, Pak Krisna. Oke. Enough, itu saja Pak Krisna.
Mungkin itu aja dari saya.
Baik, terima kasih. Selanjutnya Pak Gulam Shah ya. I'm sorry Pak Gulam Shah, difficult to understand what question is exactly. Maybe you can ask directly to Asawa Sensei. Please, Pak Gulam Shah. Hello. Okay, I think we miss him, and maybe I invite Abu Venita, and after that, Neti, where is Neti? You want to ask directly? Okay. Abu Venita, please, you can ask by yourself.
Yes, thanks for the time, Ariel. Thank you for the nice presentation and giving us new insights, Sensei. My question is related to possibility of simulation on another type of roof window. By looking at the design of the Dutch colonial design in Indonesia, we have double layers of window. So glass window on the inside and then the roof window on the outside. And I just want to ask, have you considered to do a simulation on such design? Is it possible to have the roof that you have simulated in your research into the same design as we have here in Indonesia? Thank you.
Thank you. Thank you, Bu Venita. So yeah, you have 3 questions. One from Bu Venita, I think you already understand, and the second is about the name of the software, what you kind of the software you use, and the last is about the in the settlement area you usually use asphalt for the land cover, maybe for the main road, something. Yeah, I know that it has a huge impact on the urban heat island, right? So he curious about is it possible to change from the just ordinary asphalt into the like bioporous asphalt to substitute that asphalt for the settlements area, and particularly in Jakarta, he said. Thank you.
So first one is the name of software, right?
Yeah.
Okay.
Yes.
Okay, so first, my answer to the first question is the name of software is for CFD simulations is I use Stream. Stream is mainly used in Japan. So Stream is a very nice graphical user interface and easy to use, and but especially for the researchers, not the practitioners. So yes, we use such a stream for our researches, but there are some recently the CFD simulations that can be also how to the student or practitioners and designers can use in their design stages or their education or something. So you can select now the different types of such softwares from the very professionals to the more easier to use ones. Yes. So we use a stream, and surface temperature simulation is developed by our groups. So this is called a thermal render. Thermal render. Render is a rendering. Thermal render. Yeah, thermal rendering. So thermal render. I'm sorry, difficult to pronounce, but this is a software that we develop.
That software publicly open, or we have to
yes.
no copyrights?
Yes. Now that the software can be purchased in Japan, but the one with the I'm the developer, but now we consider that this software is only work on the how to say the one CAD software. So CAD system is based on the our software thermal render. So this is and also not closed and not open. So now we change this system to open software, open source, and using open 3D modeling, as I explained. So now we are moving to the phase that we should open, and everyone can use the software and systems. Yeah. So yeah,
Looking forward.
looking forward. Thank you very much. So this is now phasing, not close and now open. And the second one is yes.
Yeah, but
Sorry.
touching the louver into Windows.
Yes.
Not
In,
separate.
sorry, yes, I will. Yes, attaching the windows is also okay. So that is the best condition for indoor environment. So if that in case of the loosen, so if you can put the louvers on the just facing the windows, it's a very good situations. Good, okay. So I think there is a selection, one of the good selection for loosen. But in my case study is the detached houses. So the residential houses on the ground. So that in that case that we need to go out and we need to use the outdoor space. So we put the louvers far from the windows. So this is the reason. So there may situation may be different. And if you go out in the lessons, if you need to put, you can put the louvers on not on the face to the window, not on the directly close the windows, but on the how to say the edge of the terrace. Yes, railroad. How to say that? Yeah, such handrail or so. So you can put on the. You can select the distance, but yeah, most performance is just closely contact to the window. So this is best.
Yeah, as you may know that this is in transformer building. Sometimes we have 2 layers of window.
Yes.
First is louver window. So we normally open outside, and then a glass window. Normally
Yes.
open inside. So it depends us if we want to receive the wind. So we only open the louver window and close up louver the window and just open. And the next sorry. And the next question is: do you have any plan to do some research or maybe simulation about this window system?
Okay, I'm sorry that I don't fully understand your question. I'm sorry. Now I understand.
Okay.
Yes. The position now. Yes, this is a very important research topic for us. How to design the windows. So this is not only for my research, but this is the collaboration with Mr. Home. No, sorry. The Hiroshima University or the YKKP's Mr. Holmes and also the other institute, of course, the Puskim or the universities in Indonesia. So this is now we have conducted the collaboration research is the best window design with the combination of such a window design and also the attached ones. Okay, now I understand what is your question. Yeah, thank you so much.
And the last about the bioporous asphalt.
Yeah.
In replacing just asphalt for the settlement area.
Yes,
is this effective to?
Yes, it's effective, but in the settlement of the, for example, the road surface should be very tough. road surface is very tough, so it's a bioporous. It's not tough. So, for example, the pedestrians or such open spaces are okay, but you need to select based on the space. Okay, so but I think in my understanding that if that we put such a bioporous materials and they can absorb the water and something is like that can provide the coolness to the people for the pedestrians. So I think that this is not the conflict between the such a toughness of the road and also the comfort. Yes, I think so. Yeah.
Karimasta. Now I think we are running out of time, so I'd like to invite the last session for the Q&A. So now I'd like to invite Neti and Inat, and I see our colleagues are eager to ask something to you, Sensei, and also Fani Kusumawati, and the last is from Directorate PS Prasarana Strategis, Miss Anita. So we have 4 questions for the last session of our Q&A. So please.
Inat first, Pak.
Okay, Inat, go ahead.
Yes. Okay. Thank you, Sensei, for your presentation. My question is, First, what we can do if in the validation step, the simulation result and experiment result is different. I mean, do we have to recalculate the simulation first or do the experiment again? And the second question is, as we know, in Indonesia, there is dense residential and settlement. So which passive cooling techniques that can apply in Indonesia in that area? Thank you.
Okay, next Inat or Fani Kusumawati. Okay, Fani.
Okay, thank you for the opportunity. Sensei, I would like to ask if there is any specific criteria in selection of the vegetation that we use in experiment of landed house or the Marunouchi street case. What kind of type the plane that can give the best effect on passive cooling? Thank you.
Okay, Neti.
Terima kasih Pak, saya izin pakai bahasa Indonesia, bahasa Inggris saya masih belepotan. Sensei, tadi kan dari penelitiannya Sensei itu ada desain bukaan jendela, dan bukaan jendelanya itu bukaan dua sisi gitu. Nah, apakah ada desain lain? Ya, apakah ada desain lain dari penelitiannya Sensei yang tetap mengutamakan airflow-nya maksimal, tapi penggunaan ruangnya itu lebih minimize gitu. Ya, terima kasih.
Okay, I got it. Thank you. Okay, thank you for your questions, Mbak Neti, Teh Neti. Ibu Anita from DITPS.
Good afternoon. Greetings for Asawa Sensei. Thank you for the presentation. It's very inspiring, and maybe I'm thinking about another factor in thermal comfort is about the airflow. So I just wonder if you or your colleagues have any experiment also including a factor of airflow, for example, how the velocity or how to make a passive design to optimize velocity, and how to directing the flow of winds, the wind or the airflow to optimize the thermal comfort indoor or also outdoor. So that's the basic of my question. Maybe I hope you can understand that. But it's my curiosity. Thank you.
Okay, thank you, Bu Anita. One short question, Sensei. I'm sorry, this is from YouTube because now you are live in YouTube. From Sindusiro, now he's one of our colleagues. Now is take his PhD in Tokyo Metropolitan University. Right now he's in Tokyo. So he asked about, is there any comparison of the results between the experimental louver and conventional shading device? Thank you. That's very short. Is there any difference? Is there any comparison of the results between the experiment louver that you mentioned before with the conventional shading device? Is there any comparison, and which one is better? Okay, so we have 5 questions from Inat. I forget Fani, Neti. But from the Neti, sorry, I forget to interpret. He asked about in your simulation, you only present about the pivot windows. She asked about do you have any research, other research, for example, to investigate other type of windows? Because as you may know that this type of windows take so much space when open or closed, right? But with the minimized space, but still improving the indoor thermal environment. Thank you.
So first question is from Inat-san. Validation process. Validation. You asked me the validation process and what we change. If that there is a difference between the simulation and the experiment, what we'll do. Yes, of course, that we accurately measure the data of the indoor temperature and humidity or wind speed by the measurement. So yes, we rely on the data of the experiment. And then that if there is a difference between them, yes, we first understand we first check some boundary conditions or parameter of the simulation may be a bit different. So we change such parameters and the settings for the boundary condition or something. And then that yes, if their result is okay, yes, okay, this setting is validated. But if there is some discrepancy, differences between them, yes, we go back to the experiment, and maybe there may be some errors and some uncertain factors in the experiment, and then that we check both. So this is the fundamental, the process first that we check the simulation settings, and then that we check the measurement. So, but this is my way. So I'm not sure this is the general one also, but we do such a things. Thank you. And second one is what is the best passive cooling techniques in Indonesian houses, or so? Is it okay? Yeah. Yes. Of course, shading is very important. Very solar radiation is very strong, and so we need to make a shade by the trees or louvers or something long eaves, and also the ventilation. Ventilation is very important for hot and humid climate. Without ventilation, we cannot achieve the summer comfort. And third one is that, as I explained, that in case of the outdoor temperature is higher, the hotter air can stored by the materials summer storage, as I mentioned before. So in that case, that we can provide such a night ventilation. Yes. So I think these are the very effective hot and humid climate in Indonesia. I think so. These three maybe. Of course, the insulation or something are needed, but these are not passive cooling techniques, so I don't explain that point. Yes, it's okay. Oh, yeah. And third one is that the vegetation, type of vegetation. So selection of type of vegetation is that we consider the function of them in summer environment. In the Marunouchi Street Park, that most important is of course the shading to the like a canopy, tree canopy on the street. So but there are originally the very nice the Delcova trees on the street. So yes, we check the performance of them. But in outdoor spaces that we can more small, we can enjoy the more small trees, and we check how their transpiration performance, how they release the heat, water to the surface, to the air and something. So we previously checked how each tree plants transpirate the water from the root to the atmosphere. We check each species. So, but that depends on the scale and target site, and also what kind of the effect we need to obtain, shading or transpiration or something. Yes, so I don't have an answer what is the best. Yes, we select case by case for such situations. And also third one is a window type. Yeah, yes, this is just collaboration research, not only by myself, ourselves, but also with the YKKB and Hiroshima University and other institute in Indonesia. Yes, we check what kind of the window types are best performance in indoor spaces. And also this depends on the wind direction of from the south or from east or something. So wind direction, and also how it can open and how it can catch the windows, like a window catcher. Full open, it can be like a window catcher, then that can go enter this one. But not only the horizontal wind direction, but also the loosen, there is a vertical wind, like go down and go up. So in that case, this kind of the horizontal pivot windows are best to capture such a vertical windows. So that depends on the outdoor airflows. As we already published the paper to the Building and the Environment, the journal. So if you want to check the more detailed, yes, I will give you the paper on the Building and Environment journal. Yes, that's a very detailed measurement result, and simulation result are shown Yes. And yeah, final. Is that a final? Third one, you guess. Sorry.
Do you have any study or something, but not only shading, but also wind, but also wind flow, and related to the thermal comfort?
Yes. Not only the shading, but also the thermal comfort we have conducted. So that depends on the shading effect and also the wind speed. Wind speed at the occupant space is very important. So what kind of the window type and louvers or something provide a good air into the occupant space. So for example, if I put on the this space, so how that window come from the outside can effectively reach to this space. So this is very important to the wind flow. So we have checked and how it can achieve the thermal comfort of this occupant areas. Yes, thank you.
Okay, thank you. And the last?
Yes,
Is there
I forget.
a comparison of the results between the experiment louver with the
Commercial louver.
shading devices?
Yes, honestly, yes. Previously, that not the conventional louvers, because that previously that we consider that the louvers is put on the other like a fence between the outside of the residential space and between the road and the inside of the housing space, like a courtyard. So we consider other fence firstly. So we check comparison between the original fence and also vegetations like as a hedge. We compare the performance for the wind, how it passes the windows and how the temperature change or something by the such outdoor devices. But now we are aware that this can be if we can close to the windows. Yes, this is a very close to louvers. So now from now that we want to compare such a performance between the conventional ones and that ones. Yeah.
Okay. Thank you very much, Asawa Sensei, for your just time being. So yeah, we have already until a schedule 11:30. So very unfortunate, I have to stop this session for Q&A. So if I may summarize from this from this technical assistant. So yeah, I would like to underline but as Asawa Sensei mentioned at the very beginning, that now the climate change has jeopardized our daily life, right? So we have so many problems because of the climate change. So we have to tackle down that issues. So Asawa Sensei mentioned there are at least 3 points, 3 ways, 3 paths to tackle down these issues. One is measures in outdoor space. It means we have to creating a better outdoor microclimates, and then measures in building designs, and last is the control by mechanical means. So these 3 measures, countermeasures, cannot be separated. Right? We have to comprehensively dealing with these 3. Otherwise, we will not achieve anything. So during the discussion, we have discussed so many things, so many ideas that that's bring us to the one direction. That's in order to discuss all this idea, we have to use tools to validate whether our idea can be used efficiently or effectively. And Asawa Sensei has introduce us and demonstrate to us that simulation could be one of the best way to validate how our idea could be implemented, could be applied in order to achieve sustainable building and so on and so forth. Yeah, that's, I think, what can I summarize for our discussion today. I, as a chairperson for this session. As I mentioned, I think you have to select 2 best questions. We have to give present for the you just say about what, and then maybe computer will help whose questions belong to.
Yes, all questions are very nice and very convincing, and some questions are a bit difficult to answer. Honestly say, yes, this means that very nice question, good questions. And two, isn't it? Okay, two. Okay, two. Okay, so yes, the younger is better or no? Younger is better or?
It's
It
up to
depends.
you.
Okay.
Whichever.
Okay, so the very nice, and what I think that this very nice question, a bit difficult to answer is that yes, I'm not sure, I forget the name, but the how indoor temperature of the building materials are higher, become higher during daytime.
Pak Rusli. Okay.
Yeah, that's a very nice, very important point.
Okay, Pak Rusli,
this is
satu.
very nice. Yes. And second one is the I think the Inat-san's question. Inat-san.
Inat-san.
Yes,
Okay. Omedetou gozaimasu. Inat-san. Okay, so we have two best questions to be given present from Balai Sains Bangunan. So congratulations for the best questions. That's very impressive. Okay. Yeah, I think I have already summarized the results of the meeting. So yeah, the most important from our discussion is we have to validate before we make any decision in design and something. And simulation can be a tool to check whether our design model is appropriate or not. Okay, now I return to how to say MC, Master of Ceremony. Thank you very much, Asawa Sensei, for your very nice presentation and very fruitful discussion. Let's give big applause for Asawa Sensei.
Terima kasih. Thank you.
Baik, terima kasih Bapak Ariel dan narasumber Dr. Takashi Asawa atas paparannya. Sangat menarik, tentunya juga membuka wawasan kami mengenai materi hari ini. Kami akan memberikan sedikit cenderamata untuk Dr. Takashi yang nanti akan diserahkan langsung oleh Bapak Ajun Haryono selaku Kepala Balai Sains Bangunan. We would like to say thank you to Dr. Takashi Asawa for these amazing presentations. Also to Pak Ariel as moderator. We received so many useful information that we can expand our knowledge about this presentation about simulation-based design for built and urban thermal environments. For remember today's event, we already prepare some gift to Dr. Takashi Asawa. Kami persilakan Bapak Ajun untuk ke depan, Bapak. Baik, Bapak Ibu, untuk acara selanjutnya yaitu ada post test. yang akan dipandu oleh panitia. Di sini sudah ada Bapak Rido yang akan menyampaikan terkait ketentuan postesnya. Kami persilakan bagi Bapak Ibu untuk menggunakan nama asli, karena di akhir postes akan ada hadiah menarik untuk Bapak Ibu yang menduduki peringkat teratas. Kami persilakan Bapak Rido.
Baik, terima kasih Teh Putri. Bapak Ibu, kami informasikan bagi Bapak Ibu peserta bimbingan teknis Sains Bangunan kali ini, setelah menyimak presentasi dari Dr. Takashi Asawa, Bapak Ibu sekalian dipersilahkan untuk mengisi postes atau kuis melalui Google Form pada link yang akan diberikan di chat, di kolom chat Zoom, atau melalui scan QR Code dan pilih form postes di layar Bapak Ibu. Akan di-share screen oleh panitia. Pengisian postes ini juga sekaligus untuk mengisi kuesioner dan daftar hadir bagi Bapak Ibu yang hadir secara online. Mohon dapat mengisi dengan menggunakan nama dan kontak asli, karena data yang diisikan akan digunakan sebagai data yang tercantum pada surat keterangan keikutsertaan elektronik yang akan kami kirimkan nantinya melalui email masing-masing. Serta akan ada hadiah menarik bagi beberapa orang yang berhasil mendapatkan peringkat postes tertinggi. Pengisian postes dan kuesioner kami tunggu dan akan dibuka hingga pukul 12.00 waktu Indonesia Barat. Terima kasih.
Baik, Bapak Rido, terima kasih. Kami silakan Bapak Ibu untuk mengakses postesnya pada link yang sudah disampaikan tim panitia di kolom chat. Baik, Bapak Ibu, selanjutnya penutupan kegiatan bimbingan teknis oleh Kepala Balai Sains Bangunan. Kepada yang terhormat Bapak Ajun Haryono, kami persilakan.
Assalamualaikum warahmatullahi wabarakatuh. Yang terhormat Ibu Direktur Bina Teknik Permukiman dan Perumahan, Profesor Takashi Asawa dari Tokyo Institute of Technology, para direktur di lingkungan Ditjen Cipta Karya dan Ditjen Perumahan atau yang mewakili, para kepala subdirektorat dan kepala balai atau yang mewakili, dan seluruh peserta bimbingan teknis sains bangunan baik yang hadir secara luring maupun daring. Selamat siang, Alhamdulillah, puji syukur kehadirat Tuhan Yang Maha Esa, kita semua telah mengikuti semua sesi bimbingan teknis ini dengan lancar. Semoga apa yang kita dapatkan hari ini bermanfaat dan menambah wawasan tentang pembangunan berkelanjutan. Saya sangat berharap bahwa acara ini juga akan memperluas perspektif dan mempertajam pendekatan kita tentang bagaimana merancang gedung berkinerja tinggi di Indonesia. Banyak tantangan yang kita hadapi di masa depan. Salah satunya tadi adalah penguasaan desain kinerja berbasis simulasi, yang mana tadi memerankan penting dalam mencapai pembangunan berkelanjutan tersebut. Mengingat saat ini desain kinerja berbasis simulasi adalah sesuatu yang belum populer digunakan dibanding desain berbasis preskriptif, ini akan menjadi tugas besar untuk kita semua dan membutuhkan kolaborasi yang kuat di antara para pemangku kepentingan. Hadirin yang saya hormati, sebagai kata penutup, saya ingin mengucapkan banyak terima kasih kepada Profesor Takashi Asawa yang telah menyampaikan paparan dengan sangat menarik dan komprehensif di kegiatan ini. Kami harap kita dapat berkolaborasi lebih lanjut di masa depan, dan saya harap juga Anda dapat menikmati waktu Anda di Indonesia, khususnya di kantor kami di Bandung. Ucapan terima kasih juga saya sampaikan kepada panitia dari Balai Sains Bangunan yang telah mengatur dan menyelenggarakan acara ini dengan baik. Semoga ke depannya bimbingan teknik ini bisa lebih baik lagi dengan menyajikan berbagai topik yang menarik. Terima kasih banyak untuk semua peserta yang sudah hadir secara luring dan daring dan tetap mengikuti program ini dari awal sampai akhir. Saya berharap apa yang kita selenggarakan dapat kita memanfaatkan bersama dalam lingkungan kerja kita. Akhirnya dengan mengucap Alhamdulillah, dengan ini secara resmi acara ini ditutup. Sampai jumpa lagi di bimbingan teknis sains berikutnya. Wassalamualaikum warahmatullahi wabarakatuh.
Baik, Bapak Ajun. Terima kasih atas penutupannya. Untuk postesnya itu melalui link Google Form, Pak Ariel, ya. Baik, Bapak Ibu, dengan disampaikannya penutupan dari Kepala Balai Sains Bangunan, Maka berakhir pula acara kegiatan bimbingan teknis hari ini. Saya Putri selaku pembawa acara menyampaikan permohonan maaf apabila ada perkataan yang kurang berkenan. Mari kita akhiri kegiatan ini dengan bersama-sama mengucap hamdalah. Alhamdulillahirabbil alamin. Terima kasih Bapak Ibu atas partisipasinya, baik yang sudah hadir melalui Zoom meeting, YouTube, dan secara offline. Semoga kita bisa bertemu kembali di acara bimbingan teknis sains selanjutnya. Tetap patuhi protokol kesehatan dan semoga sehat selalu. Bagi Bapak Ibu yang berada di ruang di BTPP rapat ini, akan ada foto bersama. Kami persilakan Bapak Ibu untuk ke depan. Dan untuk dapat mengambil makan siang dan seminar kit di meja registrasi. Saya Putri, pamit undur diri. Salam prima. Wassalamualaikum warahmatullahi wabarakatuh.
jalan payah kumbuah, babelok jalan kayu jati, di mahati indak karuswah, ayam dan lape, ayam dan lape. Mendaki jalan pandai sikit, menurun jalan kabiaro, di mahati indah kamau be, awak tak kicua, ayam dan lape. Si kwa capang, si kwa cape, sai kwa tabang, sai kwa lape, lape laju nan karimbo, oi lama laju. Magaru yuang batu sangka, tampe bajalan urang baso, duduk taman uang tiok sabata, oi takana juo, ayam dan lape. Si kwa capang, si kwa cape, sai kwa tabang, sai kwa lape, lape laju nan karimbo, oi lama lang juo. Magaru yuang batu sangka, tampe bajalan urang baso, duduk taman uang tiok sabata, oi takana juo. Si kwa capang, si kwa cape, sai kwa tabang, sai kwa lape, lape laju Kicir-kicir, ini lagunya, lagu lama ya Tuhan dari Jakarta. Saya menyanyi ya Tuhan memang sengaja untuk menghibur hati nan duka. Burung dara, burung merpati, terbang cepat ya Tuhan tiada tara. Bilalah kita ya Tuhan suka menyanyi, badanlah sehat ya Tuhan, hati gembira. Oh, parirarapa, parirarapapapapapa. Oh, buah mangga enak rasanya, si mana lagi ya Tuhan paling ternama. Siapa saja ya Tuhan rajin bekerja, pasti menjadi warga berguna. Burung dara, burung merpati, terbang cepat ke Tuhan tiada tara. Bilalah kita ya Tuhan suka menyanyi, badanlah sehat ya Tuhan, Tokecang bala gendir tos blong angen kacang sapariuk kosong Tokecang bala gendir tos blong angen kacang sapariuk kosong aya listrik di masikit manica angka tinggalna aya istri jangkung Ali jalan payah kumbuah, babelok jalan kayu jati, di mahati indak karuswah, ayam den lape, ayam den lape. Mendaki jalan pandai sikit, menurun jalan kabiaro, di mahati indah kamau pe, awak tak kicua, ayam den lape. Si kwa capang, si kwa cape, sai kwa tabang, sai kwa lape, lape laju onan karimbo, oi lama lanju magaruyang batu sangka, tampe bajalan urang baso, duduk taman uang biok sabata, oi takana juo, ayam den lape. Si kwa capang, si kwa cape, sai kwa tabang, sai kwa lape, lape laju onan karimbo, oi lama